Okay, and we are live. Hi, everyone. Thank you so much for joining to another VJAX session. Really sorry for the slight delay. We were experimenting with some crazy stuff, but now we're here with you. Oh, okay. Sorry, I had my actually video playing as well. Anyway, this session is going to be a little bit of continuing what Stuart presented like a couple of weeks ago. I'm going to have this session called Fun with var in Java 11. And we're happy to have Nikolai with us today. Hi, Nikolai. How are you?
Hi, I'm fine. Thank you very much. Are you fine too?
Sorry?
Are you okay too?
Oh, yeah, I'm fine. Thank you so much.
Where
Um,
are you? It's still light where you are, but it's pitch black here at 6 p.m. here.
yeah, I mean, I'm in Portugal, right? So
Ah,
this is my view at the moment, as
okay.
you can see. It's not really pitch dark yet, but it's getting darker. Um, so yeah, I mean, if you like Portugal, you should come one of these days.
Keep it in
Uh,
mind. Thanks.
Awesome. So anyway, before we start, I like to tell everyone that's watching us that they can join us on our Slack channel, and you can join along and ask questions live that I'll be happy to relay back to Nikolai. So go to our website virtualjug.com, and you'll find a link there that you can join on our Slack channel, and you can go and join the live session, and then you can post any questions over there. So without any further delay, let's just get the party started. So please, Nikolai, the stage is yours. You feel free to start anytime you want.
Yes, thank you very much. Well, I think I'll start right now then.
Yes.
So, so there are two things you can really do with var. The one thing is you can just, explain how it works and how you should use it and how you shouldn't use it and the guidelines and the rules and all that stuff. And as far as I know, Stuart told you all about that. So all that is out of the picture. We have to have that in our mind, specifically how var works. Although I'm going to give you a quick introduction in a minute. But beyond that, we're just going to see what else we can do with it. And spoiler, some of the things we can do, we really shouldn't. But we'll see that. So there are lots to tinker with. First, the basic rules. As I said, I just want to give you a very, very quick 2-minute intro. Then we're going to look into intersection types and traits, two things that exist in other languages that you can somewhat fake in Java, and var helps there, and we'll see that. And then in the end, we'll talk about, maybe if we have got time left, about ad hoc fields and methods. But the two other ones, intersection types and traits, I think are far more interesting. The slides are online at slides.codefx.org. On the right-hand side, you see this talk. Although if you go there, I think I didn't push the VJAC changes yet, so you will see the different logo in the bottom right corner, but I guess you're fine with that. And then the code is online as well. On GitHub, I made a Java X demo. It used to be called a Java 8 demo, then a Java 9 demo, and then just a Java X demo. And I collect all the stuff that's new in Java in there. So there's one source branch for Java 10, and you will find all the var fun in there. So you can experiment with everything I show you here. Okay, let's get going. Rules of var. Let's start with some code. We're kind of used to write code like this, right? So looks very, very regular. It's let's create a new URL here, and then I assign it to a variable called fx of type URL, and then I open a connection, and surprise, surprise, it's of type URL connection. And then I create a new buffered reader, which is of type reader. So far, nothing out of the nothing unusual here, but it's kind of weird to repeat all that stuff, right? It's new URL. I mean, this is a connection apparently, and then buffered reader most likely is a reader. So do we really need all this stuff here? And the answer since Java 10 is nope, we don't. So if we want to, we can put var on the left-hand side, and then the compiler will infer the type for us. So the compiler sees the right-hand side of this line, sees that's a new URL. Well, I guess callfx should be of type URL then. And so in the bytecode, you will not see anything different at all. In the bytecode, you will see URL here, you will see URL connection here, and you will see buffered reader here because the right-hand side creates a new buffered reader. So this is actually different because it used to be reader before, right? So there's can be slight differences, but by and large, you just get the same result as if you would have typed the types by hand. And as I said in the intro, there are tons of things you can discuss now. How does it impact readability, and when should you use it and when shouldn't you use it? And I'm going to skip past all of that. Then we're going to go to intersection types. Let's do that next. So intersection types. What the hell is an intersection type? So before we go there, what it is, let's just give you a little bit of motivation about why you might be interested in using this at all. So say you have a type, you have something in your hand, and an instance, and what you really want to have is you want it to implement two separate interfaces, right? You want it to be of that interface, and you want it to be of that interface. And if you have control over the type, you can just implement both interfaces. Or you may want to create an interface that extends from both of these interfaces. But sometimes you can't. Sometimes you're in a situation, I'm going to show you an example in a minute, where you can't really create a new interface, where you can't change the types, where you just want to express in source code without creating a new type that you want this to be of two different interfaces. So let's say, as an example, you have something that is closable, right? So it's auto-closable. You can use it in a try with resources block. And it's also an iterator. And now you somehow want to create a method signature that says, I need something that is closable and something that is an iterator, but you don't have the chance to create a closable iterator interface. If you do that, if you be able to declare something that is closable as well as an iterator, then that is called an intersection type. And at first glance, it might seem weird that it's an intersection, because isn't it both? So it's a closable and an iterator. Doesn't mean it's somehow the union of these, because union types are also a thing, right? True, union type are a thing, but this is not a union type. This is an intersection type, because if you imagine all things that could be a closable as a circle on the left, and all things that could be an iterator at the circle on the right, then the things that are both a closable and an iterator are the small intersection violet part in the middle, right? So the intersection of these two sets, the intersection of these two, that's what we want to have. That's why it's called intersection type. So that's just in text what I just told you. Given the types, the intersection type is the set of variables that are of both types. And that means that an intersection type has the API of both types, right? If something is closable and an iterator, you can use the closable methods like close. And because it's an iterator, you can use stuff like has, next, and next. So the intersection type has the API of both types.
Excuse me, Nikolai, are you able to increase your sound a little bit?
Increase my sound, yes. Let's see. Recording devices. I turn it down because it's better.
Probably a little too high, maybe.
Okay. Like here?
Yeah, try it like that. We'll see
Okay.
how it goes.
Sure. That's why I turn it down, because it tends to be a little loud. Okay.
Okay. Thank you very much. She'll be fine now.
Sure. Okay. Then let's. What the hell? So now my mobile phone annoys me by repeating my own words. Anyway, the thing that's recording me. Okay, so let's start with some code on intersection types. Let's go here. Okay, so what's going on here? This is pretty much what I just said with the closable and the iterator example. So here we have a method called first match, and it takes an iterator and it takes a predicate, a condition, and then it streams the iterator elements. Never mind, stream is utility method that I wrote. Nothing fancy. It just creates a stream of these elements, and I call filter on it and pass this condition here. And then I want to find any element. I want to make sure that at least one element qualifies, and I want to return that as an optional. Okay, so what I'm doing here is I'm passing something that implements the iterator interface, and I'm making use of that interface by passing it to this method, which needs an iterator. Okay, have a quick look. This one takes an iterator and then does the stream support fancy shenanigans, so you get a stream back. Okay, we do it up here. We create a scanner. We pass the scanner to first match. We pass some kind of condition here. It doesn't matter what exactly it does. The interesting thing is that scanner implements iterator. That's why we can pass it here, of course. Now, this code is out in production, works like a charm. Somebody comes in a couple weeks later. We had a bug. We didn't close the scanner. It's a resource. We want to close it, but we didn't. And you, the developer of first match, you should do that. You should be the one closing that resource. Like, so maybe something like this. You can try over the elements. And there you go. You try with the elements, and that should close it, right? Once you're done with this, this gets closed. But of course, elements isn't auto-closable, so it doesn't implement closable. And that's pretty annoying because it's a scanner, and a scanner does actually implement closable. Maybe we can see it here, implements, iterator, and closable. There we go. So that means the scanner up there does have the right, the scanner up here does have the right interfaces it implements, but down here, we can't pass it down here so easily. So what we could do, that's the thing that I said earlier, right? You could create a new interface. You could have an interface, let's see, closable iterator of E, which extends closable. Oh, not clonable. Who wants clonable? Closable and iterator of E. There we go. Doesn't add any new methods. And then we expect that here, closable iterator, okay. Never see me live code? Let me tell you, I'm going to make a lot of typos. I'm not even sure whether it's closable like this, right? Yes. Okay, great. Great. Now this. Okay, this works now. We get an unhandled exception up there, so we don't need the auto here. We get an unhandled exception there because closing something can closing the scanner can throw an IO exception. So we have to add that exception here and I guess up here as well. But we don't get that far with our compiler errors. Because now that I created a new interface, of course, scanner does not implement that interface. That's what I told you earlier. That's the scenario you might be in. You might use a type that implements the correct interfaces, but you don't have control over the type. You cannot simply make it extend new interfaces. The other ways around that, you can create a wrapper around scanner that does implement the correct interfaces and forwards all the calls, but there's no good solution for this. There's no good solution to in Java ad hoc declare something to be an intersection of two other types. Or so you might think, because actually there is a solution to this, even without var, that has been working for quite some time, and that's generics. What we're basically going to do is we're going to express this here in generics. So this works as follows. Here, you're going to use something, let's call it T. And this T, declared here, extends iterator of E. This is pretty much the situation we started in. We started with something that takes an iterator, and then we pass it as an iterator to the stream method, and then we did the thing we did before, and now this one doesn't compile because T does not implement autoclosable. The compile error up here is gone because the compiler can determine that, yes, there is a T that extends this interface that matches scanner, because scanner, the class scanner itself, extends iterator of E, iterator of string in this case. So that's why it can pass that, because the scanner passes this extension check, so to speak. There's a type that aligns perfectly here. The cool thing is that here you can actually use intersection types. Call it a closable iterator. Let's keep it in that order. You can do this. E extends closable and iterator of E. And now this compiler is gone because now this thing is closable. There's no compiler error here because we can stream over, because it's an iterator. And there's no compiler up here because indeed there is a there is a type that extends both closable and iterator, and that type is scanner. Scanner itself is of that type. So that works. Of course, the scanner has some super type of scanner would implement these two interfaces. That would just as fine. The point is, there's a class that extends these two that scanner implements. And so this is how it all compiles now. So that's pretty cool. Why didn't we use var so far, right? Because there's a different situation that you might be in. Here we used it as a method signature. And we can do that in a different scenario as well. Let's say the scanner that we have here, let's say it might not always be a scanner. Let's say we're in a situation where we might get something else back. So we're basically doing a very similar thing as before. We're gonna have a static E and T extends closable and iterator of string. I'm going to come back to why it's string in a minute. Let's call that create closable iterator. Like this. It doesn't declare a return type. Return new scanner system in. Basically just pull this here into its own method. So let's quickly check where do we get a compiler. Found extends, that should be scanner is in a scanner. Scanner is of string, right? Iterator of string, closable. Oh yeah, sure. Okay. We have to cast to that type T, and this is an unsafe cast, by the way. I don't have compiler error warnings on because during a demo, otherwise you'd get tons of compiler warnings. But this you would definitely get an unsafe cast here, unchecked cast, sorry, from the compiler. But I know in this instance that has to be correct because I know that scanner implements both of these interfaces, so I'm fine here. Okay, this is still weird. Why would I want to do this? Because maybe the scanner is not the only thing that I want to return that implements these two interfaces. For example, let's say the closable iterator method has a Boolean flag. Maybe there's a scenario where it just want to create a dummy, for example. And now what I can do is I can say if it's empty, oh, there's some superfluous records right there. Then let's say return null for now, which I'm going to fix in a minute. Otherwise, we return this. So what can we return here? It just so happens that I created a type called empty here, which implements closable and iterator of E. So that just gives us another type that implements the same two interfaces. That's the only important part about empty here. Empty is a type that, just like scanner, extends both closable and iterator. That's why this works. Now the point is here, like we're in the same situation like with first match. We need to do the shenanigans with generics because we can't be sure that there's a single, because there is a single type that combines both closable and iterator in a way that lets us use it. Just like scanner does not implement our handmade closable iterator type, we can assume that empty doesn't do that either. So both of these fit this type signature here. Both of them extend both of these interfaces. But none of them does that with a single type that we can return. That's why we also have to return the T here. Okay, so how can we use this? One way to use that is to pass that here, create closable iterator, let's say true. Don't need that anymore. This works. The compiler can align all the types. It can determine that this T extends here matches is closable and iterator of string. The thing that we get back, we pass it in here. It needs to be closable iterator of something. So that's the case too. So the compiler sees all these types align. Everything works perfectly. There is no var involved. Why am I telling you this? Oh, damn it. That was the mobile phone. So why am I telling you this? Because if you want to do this now, if you want to create a variable of this, let's say we call it elements, we're going to get into trouble. Because this way we have to put a type here. What is it, closable? Then this doesn't match because it's not also iterator. Could be an iterator. That doesn't work because it's not also closable. So that's why this doesn't work with explicit types, because what we cannot do is have our intersection type here. But we don't need to. Remember that var can infer the type for us. It can not only infer the type, it can infer a type that we cannot express in Java source code. So the type that var infers here is actually the intersection type of closable and iterator of string. It's exactly this type here. But because this is the compiler and JVM understand this, but Java syntax doesn't allow it. That's why var helps us to get around the limitation of the Java language to express something that the Java machinery after the language, meaning the compiler and the JVM itself, do understand. That's where var comes in. That's also where any kind of trick that you play with var basically builds on this. It builds on the fact that the compiler can understand types that you cannot express in source code. And this way you can make things happen that otherwise you wouldn't be able to. If you got questions about intersection types lined up, put them into the chat. I'll switch back to my slides, give a couple of more short explanations, and then I'm ready to take some questions on this. So let's go back to the slides. Just give a quick recap of what exactly I do. Intersection type, when I want to have a variable of two different types, I can express that in generics, in method signatures, I can express that using generics. I create closable iterator as a return type here. And first match has it as a variable type, as a parameter type here. But the gist is you get to express that in generics. But you can't do that anymore if you want to have a variable. Well, you kind of can. You can pull this t into the outer method, and then have elements declared as t here. But that's even worse than what we've already done to the language. So I think it's fair to say that there's really no good way to have a variable of this intersection type unless you use var. And what you see down there, var elements equals create closable iterator true. It's exactly what we've just seen in code. So what do I think about that? First of all, if you use that in practice, what about that? So because I just said it's fun to experiment with that, can you use it in practice? So first of all, it combines generics and wildcards and type inference. These are not trivial topics. Depending on your team structure, that may not be a good idea to put that in, right? If all the people that you have on your team work with Java for like 10 years, then that may be fine. But you have a lot of people from different programming languages or various backgrounds. If you have a lot of beginners, then this might seriously cut into the chances of understanding a code base if you use features like this a lot. So that's some kind of downside. And then refactoring becomes a little bit harder because if you want to pull out a method, then the IntelliJ IDEA at least, and I would guess most other IDEs as well, they don't manage to put the generic intersection type, sorry, the intersection type into the generics and to make that properly work. Just as with extract variable, they're going to look for a way to put in a concrete type that blocks you. So you have to do refactor manually, and it's never good if it's cumbersome to improve the code base. But on the upside, intersection types are non-concept, so that's not a thing that I just made up here. So if that's a concept that other programming languages use, and that means that it has some bearing on the development world. So that's one reason why you might want to look into using them occasionally. And if you're really in a bind, then they might be the only thing that helps you out. And I think that's fair enough then to use them. So I would say keep this in mind, add it to your toolbox. But if you use it with care. Consider carefully whether the downsides, particularly the added complexity, is worth the upside and whether it's really the only way that you can find to properly solve a problem. If you want to read more intersection types, I've written a blog post about that. And with that, I want to do you have any questions?
Not at the moment. I just asked in the channel. Let's see.
Let's see. You know what? I'm just going to give you another minute, get something to drink. Wrong direction.
Yes, guys, please, if you're watching this and if you're on your Slack channel, please send any questions to Nikolai, and I'll be happy to relay them back to him so he can answer that to you.
Okay, if we didn't have any, let's go right on.
Go.
Okay, let's start. Let's do something with traits. So what's a trait? Or why do I want to use a trait? So let's say you have an instance of something. Let's say you have some interface, and it's an important domain concept. It's used throughout your entire code base. You're thinking long and hard about whether you want to add individual methods, right? Because sometimes they're just used in one subsystem, and you don't want to overload the interface. And so you have a type that you're not eager on extending a lot globally, but there might be local situations where you really want to add something. Maybe there's a subsystem that deals with a specific portion, and they could really use a couple of additional methods on that interface. If you don't want to create a new type, either because you would have to implement that throughout the entire code base, thus really taking away the advantage of just having it locally, or if you have other reasons why you don't want to create a new type, then there is a way, and then traits can be a way to attach this functionality, basically, to an instance that you already have there. As an example, I'm going to use something else, some different domain logic. Let's say we have megacorps. It's an interface that's important. It's used throughout the code base. And in one part of a system, we really care about, are these megacorps successful or not? And I want to attach this is successful method to it somehow. And a trait is basically something that allows that. A trait is something that extends an existing interface, but it implements additional behavior. And then you need a way to attach a trait to an instance that you already have. So somebody gives you a megacorp that implements the megacorp interface, and now you want to take your trait and just want to like somehow stuff these two together and get something that is both a megacorp and this specific trait that you want to look at. Let's have a look at that, how that could ideally look. Not in Java, though. You can see by all the red here that that really doesn't work. But this is how this could look, right? So the idea is that megacorp is that interface that's kind of important, should be defined somewhere down here, right? So megacorp has a name and its earnings and it nominally pays taxes, although probably I should return void here because that value will always be null, but never mind. That's the megacorp interface that we have here. And now we created two traits. We created an is-successful trait that somehow, maybe we could even, if we're making up syntax anyway, maybe we should try it extends or it implements megacorp. Okay, so what that would mean is somehow this trait adds this method is successful. It has a body, it has an implementation, and uses the earnings method that megacorp offers. Megacorp has a earnings method, and we're using it up here to determine whether it's successful because it earns $1 billion. Anyway, trait is evil is even simpler because all the megacorps are evil. It just returns true. But the point stands. It basically we somehow need a way to attach this to an existing syntax, existing instance. Because what we essentially want to do is this up here. Let's say we do have a megacorp. That nobody knows where that comes from. Let's say it's null for now. We have an instance. And then we want to somehow do this. We want to have something that is a megacorp and that is successful and that has this is evil check. And we want to declare it as a corp. And it should be all these things at once. Somehow. Okay. Let's see how we can make this work. First observation is, wait, doesn't this look like intersection types? Isn't this somewhat similar? Yes, this is very similar. The intention is kind of still there. You want to express in a type. You want to express a type that has the API of different types. You want to have something that is of type megacorp, so it has its API, but it's also of type is successful. It has that API, and also of type is evil. It has that API. So you really want to express that this is the intersection. The difference here is that I do not have that as a variable, sorry, as a parameter, as a return type in a method. So I'm not saying, give me something like this, or I give you something like this. What I want to do here is I want to create something like this. I have a megacorp, and I want to create something that is of this intersection type. There are three ingredients that you need here. Let's quickly jot them down. So the first one is that we need a functional interface of megacorp. What do I mean of megacorp? It means it has to have the same API, but it has to be a functional interface. Why? Because then I can use lambdas, and lambdas are poly expressions, and I'm going to explain what that means later. And this feature, this is what we're going to use, the poly expressions. Okay, so we need a functional interface. Then we need a cast. We're going to cast the result of a lambda to the intersection of our traits. And then because this pile of type, let's not call it, well, this pile of type information, you have to assign it somehow, right? And you already know what we assign it to. We're going to assign it to a var variable because that's the way to go. Okay, let's start with this. Let's start with the function interface. What we're going to do is we're going to have an interface. Let's call it megacorp delegate. And it extends the megacorp interface. Okay. This is crucial here, function interface, because we want to create with a lambda later. So now we get a compile error because it's not a function interface, because megacorp has all of these methods, 3 of them, that we're not implementing here. So megacorp delegate at the moment still has 3 abstract methods. It just have to have exactly 1. So let's start by default implementing one of these methods. Let's say we default implement the name method. What we want to do here is we provide a default implementation of that method, and want to forward this to some actual instance, because this will end in a what you get here when the stack out of stack traces error. No, what's it called? That's stupid. If at all, would be called out of stack frame error, but it's not today. But yeah, you get some kind of error when the stack gets too large, right? Because this would lead to a loop. It would call itself continuously. That's not a good idea. We need something else to call it to forward this call to. We need some kind of delegate And that's what we're going to have. We're going to have mega crop for the very successful farmer. Megacorp delegate here, because then we can call name on the delegate, right? So this is actually a useful implementation of name. It forwards name to whatever this returns. And the cool thing about this is if we already have a megacorp, then we can use the lambda expression to create this. Let me show you quickly up here. Given that megacorp we have here, what we can do is we can have megacorp delegate. I'm running out of names. Let's call it C equals mega. There you go. So this doesn't work yet because that's a compiler error, because we still have more than one abstract method in the megacorp delegate interface. But this is what we can do later, right? Because if a megacorp instance, then we can use this lambda expression to create an instance of this interface that fulfills this method signature here. And then let's quickly, can I do this? Override methods, implement methods, earnings. Huh, wow. Turn delegate.
You can even delegate them directly and I'll generate
really?
that delegate. Yeah, if you delete that.
Okay, you're gonna walk me through this. So this is somewhere in the refactoring menu again?
Yeah, no, go do like a generate, delegate.
Like, no, that's extract. That can't
no,
be it.
do the generate code. Interesting.
Maybe I think I've seen it maybe for classes and not for interfaces. It's weird to do this in interface, I would guess.
Yeah, well, I think doesn't work for methods. Then it works for instances of fields.
Yeah.
Yeah, sorry about that.
Oh, don't worry, that's fine. Would be a nice opportunity to learn. Yeah, because that's always right when you find out while you're in action. Oh wait, this should be something that the IDE can do for me.
Yeah.
Okay, so this will work now, because what we've done now, we've basically, however many methods megacorp has, the megacorp delegate interface will end up with this single method, and we chopped everything else down because we default implemented all of them. So that's pretty good. We can now go back up here, and we see that this compiles now. Okay, so we use a lambda expression here, and what we can do, for example, we can cast this to something else. Cast this to megacorp, for example. This would of course not work, because if I try this, then the compiler would want me to have a lambda expression here, that actually creates a megacorp. That doesn't work because megacorp is not functional. But if I do, I just didn't do it the right way. I have to do it like this, megacorp delegate. If I cast it to this, then this works. So I'm casting the lambda expression to this type, because then the compiler will determine for this entire block here, okay, the lambda is of type megacorp delegate. I will do that first. And once I have the delegate, it will figure out, oh yeah, delegate is a subtype of megacorp. So this assignment works as well. Okay, that's pretty good. Now we can go to get our traits. So I started with the word trait here, which is of course not a word in Java. It's called interface instead. Then we have to use extends here, because interfaces extend other interfaces. This works. Then we have to put default here, and there you go. All of a sudden, we have something. There you go. We have something here that builds on the functionality of megacorp by calling this method and provides its own additional functionality here. That's why we don't have to create a new type that implements this kind of behavior and is successful. Is successful basically is, so the type is successful, adds something to megacorp, but it doesn't require anything new, right? It doesn't require you to implement new method. It just adds a couple of things. Basically, in this case, would be usability method maybe. This could even be a thing that could be a utility method that lives somewhere else in the megacorp's utilities class or something. It really works by adding functionality that does not require new methods to be implemented inside the implementing class, because megacorp also is just interface, and the implementation of megacorp does not have to do anything to support this method. That's another important part of the trick, because now we can start doing, and we can start using intersection types here. Can This is not 100 successful. This is kind of, yes. Evil, pull this into a new line. So now we cast megacorp. So now we cast this lambda expression to this intersection here. And the compiler will realize that this entire thing here has just one abstract method. And that's the method called delegate down there. And this lambda expression fulfills that method. It has the same signature. And that's it. Now we're done. Now the compiler is happy. That's why we can have a lambda expression that has all these three types, because it still only needs to have one abstract method. If is successful or is evil would have their own abstract methods, right? If that would be Boolean is maybe not so evil, this stops work. Can't be right. Let's see whether when we remove the other compile time errors, then I would expect a compile time error here as well. So now we don't exist anymore. And see, I'm still flabbergasted by not getting a compile error here. Let's come back to that later. Because one thing that
maybe yes? Because you don't have it as a functional interface.
Yeah, but now up there should be like two abstract methods I need to implement. I'm sure maybe that is because of other compile errors, because we're not yet done fixing all the errors. Maybe that's why. Well, let's see. What I'll do first now is explain why it's important that megacorp is a poly expression. Sorry, why lambda is a poly expression, what that even means. Let's say you have something that is a supplier of string. Foo, and foo, that would be a supplier of a string, right? This is a supplier of string. Now let's say I create an interface called creator of t. It has one method called create. The astute observer might realize that, wait, this is the exact same thing that a supplier does. It's a function interface with one method that takes no parameters but returns one return value. So it's exactly the same thing that a supplier does. And indeed, I can just switch this out. If you use lambdas for a while, this is not surprising. But if you use Java for a while, it actually should be surprising, because, hey, wait a moment, the thing on the right-hand side, doesn't this have its own type? Why can't it be a creator and a supplier in all kinds of things? It doesn't work with other stuff. If you write on the right-hand side, new megacorp, sorry, simple megacorp, I think, and then that's the type, and then null, whatever. All I'm saying is I can't just simply switch the type on the right-hand side to whatever I want, because the right-hand side has its own type, and it definitely has to match the left-hand side. A lambda expression, on the other hand, can have various types. It can be a supplier, it can be a creator, it can be all kinds of things, because the right-hand side doesn't determine its own type on its own. The compiler needs to look at the left-hand side to figure out what this lambda expression could be, which is also the reason why you can't use var here, by the way, because now the left-hand side says, I don't know what the type is, have a look at the right-hand side. And the right-hand side says, I can tell you whether I fit a specific type, but I don't know what type I am on my own. So that's why this doesn't work. And that's why we need the lambda here, because we can cast it to whatever we want to use here, as long as it fulfills that signature, we'll be fine. Okay, now let's finally put in the last ingredient. Let's make the compilers go away. Let's use var here, because then, as if by magic, as you will see down here, these calls will now compile. There you go. Because, as before, the compiler infers these types, this intersection of these three types, puts into the bytecode. The compiler is happy. The runtime will be happy. Everybody's happy. And you can call it successful. And if you go there, you will even see that's from this interface here. So this way, we basically the JVM, so to speak, in letting us create a new type here that was not known in compile time. Megacorp delegate and is successful and is evil. Sorry, that was not known while the other types were written, while Megacorp was written. Now, if this was known, we decided to add these types later on our own, maybe in our separate part of the code base. And basically, we're on the fly creating a new type here that has exactly the functionality that we need. Excuse me, one. Sorry there, I'm back. Okay. Now, as before, if you have any questions, start typing them into the Slack channel. I'm going to go back to the slides and explain a little bit more of what went on here, and then we're gonna take some questions.
Yeah, we have one, and that's related as well with what we were discussing before about when you mentioned about the IDE and refactoring. So we have Amarildo asking how it affects refactoring, bug findings, etc. When you're doing this kind of stuff.
So I've been very diligent according to my own advice, and didn't use that in practice yet. So at least not in Java. I know that, well, I didn't use it in other languages either. I know that intersection types and traits are a thing in other languages, and there seems to work out fine. So there's nothing categorically wrong with them. There might be something wrong with the way that they operate in Java. And so as I said, for intersection types, that's mainly the cause is mainly complexity. And actually didn't, since I know this works, which is only Java 10 is like almost a year now, I never came up in a situation where I thought this is the only way I can fix my problem. So that's why I don't know from practical experience how good or how problematic this will be while error solving. But from experimenting with it, the main enemy you have here is the compiler. It's not the runtime system. So what I just did here, basically, the trick that I do here, for example, same thing I do with intersection types, all that I'm doing there is trying to get something past the compiler that the Java language does not have has no way to express. But the compiler still checks this. I mean, I cannot do whatever I want here. If I write successful with 2 else, I still get a compile error because there is no such method. But it's not like you can do whatever you want. All you're doing here is bypassing the language limitations to something that the compiler and the JVM still check. So I would guess that there is actually no runtime component to what we discuss here. So you're going to catch all of these at compile time. Now, if you also add more generics to the mix, then I'm sure there can be situations where we get compilation errors, for example, that you're not sure why you're getting them. So that might be a downside. But I guess at runtime, there won't be any problem. So I don't think that bug hunting really plays into this. But as I said, I didn't do it in practice yet, so I may be wrong here.
Okay, and then we have another question from, I'm not sure if that's how you spell it, but Koshla, I guess. So what exactly is the corp type, the type of corp? Can we check what the type is? He gets that, yeah, so that's a megacorp, right?
It's just this, it's just an interface.
Yeah.
If that does not answer the question, then ask a follow-up one. And even after the stream is over, maybe I can get back to you. But yeah, megacorp is just a plain interface. Okay, where were we? Oh yeah, let's quickly check finally. I want to get this compiler error now. See, I just said that we're just going to fight the compiler. So why? Huh. See, I would have expected to have one. I have a compiler here. Can we? Maybe this project has other compilers. I'm not sure whether I can execute, but let's try. Let's try building, parsing Java. Ah, haha. Nice. So we do get a compiler error, but IntelliJ doesn't know that we're going to get one because we're doing crazy stuff here. So what this means is Animus is the type that the compiler infers for this expression here. And Animus is not a functional interface, which is exactly what I would expect because we just added this abstract method together with the other abstract method on megacorp delegate. We now have 2 abstract methods, and we can implement 2 abstract methods with a lambda expression. That's why that's the error that I expected here. Now let's see. Let's execute this. Okay, we get null pointer exception. I'm sure that's okay. And actually, I did something now that I didn't want to do, because in the end, after this whole conversation, the whole talk is over, I want to joke that this is the only live coding talk you're ever going to see where I don't actually run the code. And now I ran the code. Damn. Okay, let's quickly go to traits. As I said, how to implement them. Basically, the first step is you create a functional delegating interface. Means you have the one type that you want to be able to attach traits to, in this case, the megacorp. You create that megacorp delegate interface that default implements all the methods by forwarding to the delegate. And then the delegate is the abstract method that you can use to create, that that makes it possible to create the interface with a Lambda. Then you create your traits as interfaces. You extend Megacorp. That means you can build on all the Megacorp stuff that you have there. If that API does not suffice in the new abstract methods, then this trick won't help you. And then in the end, third step is you you use a Lambda expression to create something that is of the intersection of the types that you want. Then you assign to a var variable, and then you can use it from there on out.
Okay, so we have another interesting question, which is why do we need to add the Megacorp delegate into the cast? Couldn't we just use isEvil and is successful and work anyway?
Nope, because is successful and isEvil both extend the original interface. And that means that now the Lambda expression needs to be cast to a type that needs to implement the full Megacorp API. What could work, let's see, what could work is making this the delegate here. Although I would find that a little bit unfortunate. But then this could work. Let's delegate, there you go. Now it works, yes. So if the two interfaces implement the delegate itself, then that works. I think it's a matter of taste, maybe, what you prefer. I would find it weird that the word Megacorp does not show up here. So the original type, the type that this is mostly of, it does not show up here at all. But that's maybe just a matter of taste. And as we'll see in a minute, the main problem is that you cannot use this in practice anyway. Because I got a question for the audience, or in this case, you have to stand in for the audience, of course.
Of course.
So let's say this were not null, okay? Let's say this is, I think we have actually one up there. This is Seda Krupp, the Megacorp. By the way, if someone knows what this reference to, then all hail the Shadowrunners. There you go. So let's say we have a Megacorp, and then we create Corp. Now, the question is, can this ever be true? So I'm taking a Megacorp that I already have, that apparently properly implements this this interface, no shenanigans, just a regular class. We can have a look at simple Megacorp, which is the implementing class here. Has good implementation, has an equals implementation that looks as the other one and then checks whether the names are equal. Like apparently two Megacorps are equal and the name is equal. So can this ever be true here, this line?
Well, I mean, it seems to be okay.
Yes. It is okay. And assuming that the implementation of the equals method.
Yeah, assuming that equals. I didn't have much time to look into the equals, so maybe you should show it a little bit. Yeah, yes. But it does seems to be okay. Yeah, because exactly. The instance of is gonna always be true, and if you check the name, that's always gonna be okay as well. So. Right. Because it will delegate to the other one.
Right, so that's good, right? So this works out. We get that part. That's kind of important to have equals working. Now, what about this one?
Well, the other way around, probably not, because now you have now probably it's going to fail in the reference, right?
Yeah. So the thing here is corp is corpus of this intersection type here. And its intersection types, which methods does it have? Or which methods does it define? It defines the method on all of these three interfaces. Is successful and is evil, just add a little bunch extra. What does Megacorp delegate implement? Well, the delegate method, and then the methods of Megacorp. None of these things here implement equals or hash code. Nor can they. Because these are all interfaces. And an interface can provide default implementations only of methods which are not on object. If you want to look into that, well, I'm sure there are show notes later. I can share a post that I wrote about default methods where this is in all detail explained. But the important fact here is that if you can never default implement a method on object. We can quickly try that here and see the compiler somewhere. It's Megacorp delegate. There we go. This is the Megacorp delegate. What we would like to do is this: Boolean equals object. Oh, there you go. We immediately get a compiler error. Because default method equals overrides a member of object, and you cannot override a member of object. So that means that our megacorp delegate implement equals, of course, is evil and is successful, cannot do that either. Megacorp itself can't do it either because it's interface, so nobody can implement this equals method here. This equals method here will always be the one from object. And that will never be true then, this check.
Yeah.
So if you, as soon as you put one of these things that we just created into any kind of collection, for example, things are going to break apart very soon. Like you cannot do a set, you will have the same megacorp several times in the same set. If you look something up in a map with a megacorp as a key, you may fail because it's a different instance, even though it's the same name. If you put it into list and make it contains object or index object, you get, well, it doesn't contain or something else, or mega index -1 back, because this equals doesn't work. And it even depends on how exactly the collection is implemented. Because if the collection by coincidence only uses this kind of call, where it calls equals on a good instance, passing in our weird instance, then we're fine. If it does it the other way around, it breaks. This breaks the symmetry of equals, and it will definitely break collections. So that means that although it was a really nice trick what we just did, as soon as you put that into a collection, for example, or anything else really that uses equals, then, well, I would say then you're screwed.
Yeah.
Royally. And that would be really hard to control, right? Because this, the whole thing, the whole trick about this is it's still a megacorp. Like if we would not be in a main method here, but in any kind of method, then we could, of course, return the thing that we just built. So we can return something that looks like a megacorp, the compiler is happy, everybody's happy, behaves like a megacorp, until you use any of the object methods on it. At least the ones that you want to override, so like equals and hashcode and to string. Then things fall apart immediately. And you wouldn't want that. So unfortunately, I have to conclude with you can't use it in real code. So the evaluation of this leads to, well, it has the same downsides, some of the same downsides that intersection types had. It uses lambda as a poly expression, which is really not obvious to everybody. Type inference, default methods, they're all in the mix here. They all work together to create this functionality. A refactoring becomes harder, just like the week before. If you have a var variable of these three types, then starting to extract a method from that will become kind of painful. Creating the delegated interface is cumbersome. I just did it for megacorps, which has 3 methods. Imagine doing that for list or for any other really interesting type, which is like a dozen methods. It's kind of annoying. And the most important part, though, is that it breaks at runtime in collections in unforeseeable ways. So unfortunately, I'd say don't use it in real code. You only use that if you want to impress people, for example, if you want to get a spot in the VJAX session or something. Can you have any questions about traits?
That was a couple of good discussion here on Slack. People got a little bit confused, I guess, but now they're probably understanding it a little bit better. But yeah, I mean, one comment that I will probably say is that both examples don't have really practical usages then from Koshla.
Yeah, I think the intersection type can have applications. I'm actually sure that in the past I was in a situation where I would have liked to use it, but I didn't know that that even worked in Java. Where I was in a situation, I don't remember the details, so it was like a couple of years ago, where I was exactly in that situation where I had a type, it had all the interfaces that I needed, but it's like there's no, I couldn't express that I need both interfaces. But yes, it's a rare case. And traits, well, what's the use case for traits? I think if you know that traits work in the language, and many functional programming languages have that, then you can find tons of usages for that. It's just a thing that we don't like. I'm basically a one-trick pony. I only know Java, so it's really hard for me to come up with use cases for something that I never used, right? So you will usually figure out that you have a use case for something when it's present in your mind, and you know this is a tool that I can solve problems with, and then you start recognizing these problems, and then the challenge is not to overuse the tool. But yeah, so I think traits do have practical application, just not, I would say, in the programming patterns that we're more used to in Java. Okay, I think that's about the hour that we have, right? I can quickly go into anonymous classes, but they're not that interesting either. Anyway, let me just quickly go to something. You know what? I'm just going to quickly show you some code.
Yeah. We have a few minutes left, so feel free. I mean, we started like 2 minutes later, so
Yeah.
you have 5 minutes then.
Okay, so what I want to do here is I want to add stuff to I want to put stuff together randomly, right? So in this case, I want to add fields to something. So let's say I'm not saying why I want to do that. I'm going to tell you in a minute. I have a megacorp here, set a group. I have a map of headquarters, and then sometimes in that situation, like I just want to have these two information side by side. I want to have the megacorp, and I want to have, because maybe it doesn't have an address, so I want to have the option of address as well. I want to have both of these, but I don't want to really create a new type just for that. It seems too cumbersome to create an entirely new type. So what you can do here is you can create an Animus type, new object. None of this is new. You can do that with any kind of type that is non-final. So I can do that with list, sorry, not list, ArrayList, if I really wanted to, which I definitely don't. I'm just saying that you can put any non-final type here and then start an Animus implementation. And in this case, the Animus implementation adds two fields. And the trick, once again, is like before, if I declare as object here, then down here I can't actually use the HQ field because it's an object. Object doesn't have an HQ field. If on the other hand you declare as var, then the compiler carries the information over, and down here you can use HQ. Why would, in the name of God, do you want to use this? Actually, I occasionally have that happen to me when I run stream pipelines. I never used it so far, and I'm really hesitant. I think I won't, but I'm kind of tempted sometimes. So sometimes I'm in a situation where I want to stream over something like here over the megacorps, and then basically I want to attach a piece of information to that. Over the course of the stream pipeline, I don't need it anymore. I will get rid of it. So here I attach, basically I create a new object, an anonymous subtype, which uses the corp as one field and the headquarters as another field. And then see the type hint of IntelliJ just gave up, just like, okay, it looks like a streamer object to me. Then we're going to map that, and then we're going to do stuff with the HQ. We're going to check whether it's present, and if it's not, we're going to kick it out. Also, we're going to kick out the entire object if the HQ is present. And then there's even its known method, whatever that one does, nobody cares. But the point is, another filter here. So basically, I'm evaluating the whole megacorp and HQ combination based on the HQ. And when I'm done with that, I map back out of it. I go back into a stream of megacorp, I find one, and then I do whatever else. And so in this case, for example, let's say I want to create a variable for this because it looks like this is a good intermediate result. Let's just call it any corp. So here, it's easy to extract a variable optional megacorp here, and that's fine and dandy. But now let's assume, sorry, like this. Now let's assume I actually don't want to get rid of the information just yet. I'm throwing out this map here. Then down here I have to put corp. Then it should work. Fine, this works now. But now all of a sudden, so I still have this combination for a while. Maybe I just want to map it back out later. Who knows? But for now, I still want to keep that in. And now I can't declare a variable anymore. I can, but I kind of get. First of all, I get this is a generics problem here because it infers the subtype here, and now I have to put in the cast somewhere. I forgot where. Luckily, I'm running out of time. But the point is, anyway, I think this one is wrong. So this is fixable. But the point is, down here, this doesn't work, of course. Just like before, it's an option of object. Object doesn't have corp here. In this case, once again, you need var. Now it works entirely. So this is once again the use case for var here really only is I want to declare a variable of this crazy type that I cannot create that I cannot express otherwise. But note that the type itself is not the problem. This works in Java 8 just like it works in Java 11. The compiler will know that the anonymous type you create here does have the HQ and does have the corp field. And so the compiler is happy even before Java 10 and without var, we wouldn't just need var if we want to create an intermediate variable here. And you can do something similar with methods. You can add methods ad hoc. And I don't really think that this is worth the effort. So first of all, this is kind of verbose if you do it in a stream, for example. Once again, you're compiling anonymous classes, type inference. This really is a problem for refactoring because if you have an anonymous subtype of object, then no kind of var magic or generics magic is going to make this work in a method signature. So this thing that we just had here, let's see whether I can control y. Yeah, this thing here, if we want to put this into its own method, this won't work because of this object here. And there's no var or generics magic that catches what this actually is because it's an anonymous type. I don't have any way to refer to it because it just doesn't have a name. I just created ad hoc here in this couple of lines. That's why I would say prefer the alternatives. What are they? If you want to bunch stuff together for fields, have a look at map.entry, which I misuse for this occasionally. There's even since Java 9, yeah, 9, there's a method called map.entry, which you could use here. I think that would be the way to go. Like this. Nope. Yeah. Now, of course, you cannot use HQ anymore. It has to be get key and get value, which is kind of sad. This requires, I think, some kind of lack of scruple to misuse entry for this. So I'm not saying I'm recommending it. It's just something that an alternative that I use occasionally. If you want to use real tuples, var and variable and cyclops are there for you. For example, other function programming languages all have tuples. Joule, for example, Jo Lambda has it as well. Then records are going to come up in Java in the future. And that would be a great way to create a new type there in basically a single line. That would be nice. And if you see yourself creating ad hoc methods that I didn't show just now, but basically what you're doing is you're putting, like the same thing with traits, by the way, you have all the information you need. You just want to have a good way to express it in a method. So this could usually be a utility method. This can be a static method on some other class where you just pass in the instance that you want to call the method on and all the other parameters. But it kind of feels nicer to call on the instance. So that's why I might be tempted to use something like ad hoc methods. But once again, I'm not sure that they're worth it. So what are records? This thing is a record. Not going to talk about it anymore. But this is pretty cool, coming up in Java. Who knows when? And that's that. Custom record. Not going to look into that either. There you go. So small summary. The first part is about the regular var stuff. We want to use Java to improve readability. I'm not going to go into details. Stuart covered all that. We just looked at the second half here. You have these tricks, and intersection types may be worth it occasionally. Traits, break, equals, and hash code. So never use them in any case, under any circumstances, unless to impress people and then delete the code immediately. And ad hoc fields and methods, I don't think are worth the hassle. You can just have them. There are other ways to provide them, simpler ways. And that's that. I'm done. Thank you very much.
Hey, Nikolai, thank you so much for this wonderful session. I'm pretty sure, I mean, I learned a lot just for watching you. And there were some people here on the Slack channel that were also saying that they learned a lot by watching some of the crazy tricks that you show us today. So thank you so much for bringing that session to us. It was really wonderful.
Sure.
And I already shared the links that you showed me with your blog and your slides, so people are looking into that.
Yeah. Also, by the way, I'm on YouTube, and I'm occasionally record videos there. And if you like this style of crazy guy mumbling in front of his laptop, then you should definitely come by and subscribe. So the link is on the slides. It's CodeFX on YouTube.
Yeah, and I'm pretty sure if some of the people want to reach out to you, they can do it on Twitter as well.
Yes, you can reach out me on Twitter. You can send anything to codefx.org. If you have any questions, you can send an email. There are various Slacks that I'm, like the VJAX Slack, for example. I'm just a silent observer, but I'm there as well. So yeah, if you want to reach out, there are plenty of ways to do so and ask ahead. Just a quick warning, I might sometimes takes me a while to answer, but I answer eventually.
Okay. Okay, so that concludes our session for today. So again, Nikolai, thank you so much for being here with us. So we hope that you can return to us soon enough. And thank you so much for the audiences for watching us today. So please stay tuned with us, and we'll announce a new session in the next couple of weeks. So thank you so much, and see you later. Bye-bye.
Thank you for having me. Bye.